everybody. I wanted to give you guys some guidance on how to graph sine and cosine the parent functions with a table. So I'm creating kind of a shortened version of this. I want you guys to do the whole table and the whole graph for both sine and cosine. But just to kind of show you how it works, here's a abridged version. So let's say for sine, I'm doing sine of x. We have 0. Degree conversion, remember it would be 0 times 180 over pi, because they give us radians, which is still 0 degrees. And then sine at 0, this is one where we have to use the unit circle. So right here, this is the point 1, 0. Sine is our y value, so sine is 0. So I put the point 0, 0 is one of my sine points. And if that helps you to make a list, like take out this column so you can see it's 0, 0, that's fine. The reason I put this column in is a lot of us think better in degrees than radians, but whenever we graph and we do calculus, it only works in radians. So it's good to kind of see both. Okay, so the next one I wanted to do was pi over 6. So pi over 6, I'm going to multiply it by 180 over pi. The pi's cancel. 180 divided by 6 is 30 degrees. So this is going to be one of our special right triangles. So 30, across from 30 is 1, the hypotenuse is 2, and the base is square root of 3. Sine is opposite over a hypotenuse, so 1 over 2. So f of x is 1/2. Notice that I labeled mine since it was divided into fourths. I don't like this setup exactly, but it helps doing it for the first time. Later we'll be talking about better ways to set this up, but I set it up as 0.25, 0.5, 0.75, and 1. So at pi over 6, I'm going to go up to 1/2. Okay, now we're going to do pi over 3. So pi over 3 times 180 over pi. The pi's cancel. 180 divided by 3 is 60 degrees. And so if we're looking at that special right triangle again, got 60 degrees. This is root 3, 2, 1. Sine is opposite over hypotenuse, so it's root 3 over 2, which is like 0.8 something, whatever. So we're going to go there. It's not quite 1. That looks too close to 1 for my liking. Okay, and then we're going to do pi over 2. Pi over 2 times 180 over pi. Pi's cancel, that's 90 degrees. So I look at my unit circle again, 90 degrees right here. That's the point 0, 1. Sine is the y value, so it's 1, so I go up to 1. So far it's making this like curvy thing like that. Okay, so now I'm also going to go backwards for you so that way you can kind of see how the negatives work a little bit, and then you guys can finish the graph. So negative pi over 6. You don't have to recalculate that. It would just be negative 30 degrees. So if I do negative 30 degrees, I'm down here in the 4th quadrant, and this is negative 1, 2, and root 3. Ooh, my negative 1 went away. And sine's opposite over hypotenuse, so it'd be negative 1/2. So I would go down to negative 0.5, negative pi over 6, negative 1/2. Then I'm going to do negative pi over 3. So negative pi over 3, we already know that's negative 60 degrees. So 60. Across from 60 is negative root 3. This is 2, 1. Sine is opposite over hypotenuse, so negative 0.8-ish, 0.9-ish, close. So right there, if we round, so negative root 3 over 2. I didn't write these in. I am so sorry. This one was 1, and this was root 3 over 2. And then the last one we're going to do is negative pi over 2. So negative pi over 2, we're going backwards to negative 90 degrees. That's right here. Negative 90. This would be at the point 0, negative 1. Sine is our y value, so that's negative 1. And I plot that point. And so you guys will continue plotting these points until you get to the end of your table. After you do sine, do cosine, and then the next day your assignment is to go through the list of things and make a poster to compare them. The reason you're making a poster is just to practice communication and the vocabulary terms that are gonna go along with this unit. And then we'll meet on Zoom and we will talk about this. Hope you have a great day. Bye.